Hello everybody, this is Group 1. We will be presenting our final project about SAP 3 Arsitektur. Ini COA final project. Our group consists of first is Ananda Arti Udigdo, and second is me, Inyoman Utama Suraja Kadita. Third is Brian Daniel, and fourth is Farhan Arya Priyatna, and fifth is Gibran Muhammad Iswar Syahrid. The first thing I will explain is what is SAP3. SAP3, or known as simple as possible computer, is a simplified computer architecture designed for educational purpose, and it is described in the book of Digital Computer Electronics by Albert Paul Malvino and Gerard A. Brown. There is three kind of SAP: SAP1, SAP2, and SAP3. SAP2 and SAP3 are fully Turing complete. Next is about our instruction. So we got instruction 1, and this is the instruction. So what we're going to do is to load all this data first, and then we do this instruction. The tools that we use are, the tool that we use is Simulator 8085. It is on the website, so it is easy to use. So the first thing to do is, for my part, is to load the memory, these 7 memories. Okay, so we got 7 memory location. I already translated to the instruction code, or we usually call it the assembly language. So first is to load the register H on 2000. So what we need to do is to view the memories. We got address of 2000, so just put 2000 here. So we got view of 2000. We got 2000 register view, and it's going to be from 2000 to 2006. So from here 2000 and to 2006. So this thing will change into this. So now I will be doing the execution. So first we need to build the instruction code, and then run it one by one. So first is to load the memory in the register H, or here HL, into 2000. So it is 2000 now, and then MFVA, so we make A into 10H, so it has 10 now. Now we move, this means inserting this data into this address. So 10 into 2000. Now it has 10. The same goes for this. So 2001 has 20, and then now it will be there. Just like that until the 2000. Now we had this fully insert, so we got this instruction fully done. So the next part will be explained by my friend Guna or Farhan.
Hello, my name is Farhan. Right now, I'm gonna continue the explanation. I'm gonna talk about load register. So, as you can see, I'm using this website. Then we put the instruction to this area. Then for that, we set the memory view to 2000. So after that, we build and run. Okay. Now I'm gonna run it one by one until to the register. Okay, here. Right here, this is the instruction for load register. Load register is simply uh, load register is simply moving data from the memory to register. So we just simply changing the register one. Okay. We got this instruction right here. It means that the B is 01H, and because the B with C, then the C is 23H. Then if we run this instruction, then we see this value, the B and the C, is changing into 0 times 01 and to 3. And for the next instruction, we have H, because H with L, then H is 1E, H, then the L is DDH. Then if we run it, so you can see the value is changing into 1E and DD. Okay, that- that's all for my explanation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Gibran Muhammad Miswar Said from the Group 1 of this Computer Arsitektur group. And I'm here to explain about the DAD operation part of this section. So just continue the explanation here. Okay, so here we are having the script of this form, and then we just gonna explain this the DADB part. So this is my part of the section. Okay, so DAD is actually stands for double add. So basically it's the operation to add a register memory into HL part. The HL register is actually part the content. The HL register is actually works as accumulator, and then because it's the 16-bit content of RP will be added with the HL register pair content, and some thus produce will be stored back to onto HL again. Okay, so here we are having the BC register address here. So let's try to test by compiling it first here. So yeah, it is compiled and loaded to memory location 0x0800. Okay, so we're just gonna run our instruction here. Okay, so let's skip into my part. So yeah, we have here the HL register, or the accumulator here has the register of pair of 2006, and then the BC here is addressing on 0123. Okay, so how about it when we add the DADB? So as we know here, the DADB here stands for stands in opcode in 09, and it contains only 1 byte. Actually, it is adding the previous so the BC register into the HL. So let's see when we add it. So when we arrive on the AD part. Okay, so look, it is changing. HL becomes 1E DD, and the other L's affecting the, the transformation. And so yeah, so basically the DAD is adding the register, the BC register into the accumulator where it is an HL register. So yeah, that's it. Thank you for Thank you for your attention, and we will continue to the next part of this video.
Uh, Hello everyone, my name is Daniel, and in this part I will explain about the loop part. So this the memory that I use is from 1100 until 2000. Then I and then we will go into uh loop the loop part. It's yeah, and before that we need to go to the definition about move at move at GNZ and GCRL. So in this, the move is so we moving the address from memory to the register A and the adding L. So yeah, we adding the register A with the register L, and moving rate is the same as it. And then go to the DCRL is to subtract the register L with 1. So, and in GNG2, so it's mean that jump if not 0. So it will be jump if the level from the radius is not the same as 0. So this and the last is ILT. So it will stop if the output is uh, so it will stop and will be turned the output. And then this part we just need to focus on the HL, this one. And then I will go to Xenon. So we add the L first and then move it to the M, from M to the A, and then DCR it, and then to go to the ZNG2. So this, because we know that, look, this is the FF, so it's not the 001. So it will be go back to the move AM. Yeah, it is go back to the move AM, and then move again. And this TNs loop, we get the FA, so this is FA is decreased by 1 alphabet, and so on. So it will be FD and then grow 20 MC and so on, FP, and then go to the FA. So here, so when it will be stopped, it will be stopped if the FA will be 0. So the FA will be 0. So it will be stopped when HL is 2000. So it will be stopped. And for the next part, it will be explained by Ananda.
Okay, so hello, my name is Ananda Artiwidigdo. Yeah, and now I will continue uh, about this part, the loop part that Brian already explained, but I will explain it or give more details about it, maybe. Yeah. So wait. Yeah. Because our question or problems or yeah the one that we get the yeah I think the question or what is it? Wait. The option. Okay, the option. Okay, so because we get the first option, uh, we fill, or yeah, we put this value 10, 20 till 70 to memory address 2000 till 2006. So we will go to there. We will go there here. And I'm sure that Manu already explained about this. And so yeah, to the loop. Okay. So yeah, Brian already explained about what is move AM, add L, move MA, DCRL, and JNZ loop. So I guess I will just skip that and go to 20, I think 20 FA. Okay, sing from this one, I guess. Okay, so this is where Brian's last explanations until FA from FF. The value of memory 20 FA is filled with FA. Okay, so I will continue from there. Okay, so uh yeah, uh because the previous value is FA and we decrease it by 1 on L, this one, and the register L, you can see here that it is changed from FA, which is F10, but this is hexadecimal, so FA to F9. And then because it is still F9, then we need to loop it again. So jump when not zero to loop to this one. So okay. And after that, we can see here on the accumulator register, I believe, that the value is FA. FA, same as before here. And then what else? Okay, there's flags. You can see here that there is 5 flags. There is 0 flags, sign flags, parity flags, and then I wait. And wait. Okay, and carry. So as you can see here, the S flags or the sign flags is on 1. So wait, it is checked, but I don't think it is uh uh the value of A is less than 0. So I'm not sure about that, but yeah. Okay, so here on the parity flags, you can see here that the value of F9, which is F9, is odd. So we can see here that because F9 is odd, and that's why P is checked here. And then we can see here on the program counter, the program counter will not exceed like the on this position it is on 0 at 3 1, and then 0 at 3 2, 0 at 3 3, 0 at 3 4, and then 0 at 3 5, and then because it is jump when not 0,
then the program counter will go back to 0831. Yeah, like that. And then because it maybe took me will take me a lot of time to expand the looping process one by one, because the looping process will start from here and then we will end from here. But I think I will start maybe explaining some things here, because there is something here that is kind of interesting, I guess. Yeah. Okay. I will just okay. And also, as you can see here, the parity is 0 now because it is F8. And as you can see, F8 is 248. So yeah, that's about the flags. And then yeah, I think I will just run this instruction until we get here, I guess. Yeah. So yeah. So almost there. But you can see that it keeps on decreasing. We started from FF and now we already at 41 or 41 because of the DCRL or decrease L and jump when not zero to loop. Okay, so here uh move AM. Okay, so move AM. So you can see here that A is 07 here from this one. Oh, maybe wait. Yeah, but the interesting things about this process of loops when it reaches here is that you can see, okay, so there is add L here, and we can see that L is 06. And then if we continue, so move M, memory move, yeah, move MA. As you can see that from the decreasing of from 07 we get 06, but because there is already a value here which is 70, and we get, and there is also an L here. So when we get to this part, the value of L is 06. So we add the 70 with 6 and we get 76, and that will be the same as the other, as for this one, the 10, 20, 30, 40, 50, 60. So the 60 or the on the memory 2005, it will be, the value will be changed to or added by 5, so it will become 65, and then this one become 54, 45, 34, wait, 76, 65, 54, 43, 32, 21, and then 0. And then Yes, as you can see there, 54, 43, 32, 21. Okay. So in L, there is the value of it is still, wait, okay. So when we get to this part, the L value is 0, so 0, 0. So yeah, it will exit the loop and go to halt. Yeah. And so the flag of 0 is 1 now. It is checked because it is now 0. And also, yeah, the accumulator. So you can see here the VC and then also the L, which is now 0, 0. And yeah, I think that's all from me. Thank you for watching, guys.